Okay, let's explore our favorite topic, those inverse trig functions with regard to antiderivatives. So let's recall the derivatives of the inverse trig functions. So we'll start with the derivative of the sine inverse of x function, whose derivative, remember, is this really interesting derivative that doesn't have to do with trig at all, seemingly. It's an algebraic expression. It's 1 over the square root of 1 minus this argument squared. 1 over the square root of 1 minus x squared. And similarly, the derivative of the cosine inverse function is the same thing with a negative. And so now, if we're looking at the corresponding antiderivative, if we look at the corresponding antiderivative, we actually see that these two outputs of the derivative are the same, save for this negative coefficient. So what this allows us to do is say, okay, well, what is the antiderivative of 1 over the square root of 1 minus x squared with respect to x? And so this may be a bit difficult because now you have to recognize the algebraic expression and turn it into an inverse trig function. That takes some practice. And believe me, in Calculus 2, you should get lots of practice with that. But what we get here is, well, the antiderivative of 1 over the square root of 1 minus x squared is sine inverse of x plus a constant, or if I use this statement here, I can move my negative over and I can say it's the negative cosine inverse of x plus a constant. Now, typically you're going to go with the positive sine inverse of x. That's the most natural approach, but I wouldn't be doing any justice unless I mentioned the other possibility. So that's the antiderivative of this algebraic expression using an inverse trig function. Let's look at the tangent and cotangent inverse functions. So my favorite inverse trig function to differentiate is the tangent inverse function, because the derivative of, sorry, my hand's not working as well as my brain is. The derivative of the tan inverse function is 1 over 1 plus the argument squared. There's not even any square roots. There's no subtraction. It's so beautiful, right? Similarly, the derivative of the cotangent inverse of x function is the same thing, but negative. So just like before, when we translate this to antiderivative, now we can say that, well, the antiderivative of this algebraic expression, 1 over 1 plus x squared, is, well, it's literally tan inverse of x plus c. That's the natural choice. Or we could call it the negative cotangent inverse of x plus a constant. Okay? So very similar to the sine and cosine inverse functions. It's just you have a different derivative, thus you've got a different function you're anti-differentiating here. Okay, last but not least, maybe they are least. I don't really care for these derivatives as much. They're harder for me to remember. The derivative of the secant inverse of x function. It's kind of both. It takes something that's not a square root along with something that is a square root. And so it's 1 over the argument x times the square root of the argument squared minus 1. So this guy takes, instead of 1 minus x squared, it takes x squared minus 1. Similarly, the derivative of the cosecant inverse of x function is the same thing, but negative. And so I'm sure you can guess what we're going to write here for the antiderivative. the antiderivative of 1 over x times the square root of x squared minus 1 with respect to x equals either secant inverse of x plus a constant or negative cosecant inverse of x plus a constant. So this is a great review of the derivatives of the inverse trig functions. I'll try to put a link to a video discussing those up there for you if you need to review those. But all we're doing is reversing the process for antiderivatives.